Hey everybody, it's Ms Moran, and we are getting ready to start our first video in our arithmetic, or in our series and sequence units, and we're going to be starting with arithmetic sequences. So we already discussed in class a little bit about the vocabulary and how to pronounce a lot of what we're going to be working on. So make sure you're referring back to that if you have any questions about why I'm naming things the certain way. Okay, so in this video we got two major things we're going to be working on. The first one is to introduce arithmetic sequences, what they are, how we can recognize them, and then we're going to be working with them to be writing explicit and recursive definitions. There's going to be two different types of way of defining a sequence, and it's not defining in words, it's defining using algebra. Okay, so what is an arithmetic sequence? An arithmetic sequence is when you're going to find what we call a common difference between each term. So this common difference, let's just come up with this. I'm going to come up with a sequence here, 7, 10, 13, 16, and I'm going to use the ellipse to say it goes on infinitely. It doesn't have to go on infinitely, that's fine. It would just be a finite, meaning not infinite, finite, finite, F-I-N-I-T-E. That means it terminates and it ends at some point, but this is infinite, it doesn't matter. The point is that between each of these terms, we see a common difference. In other words, I can subtract any two terms, any two consecutive terms, and I'll get exactly the same difference between them. So I can pick 16 minus 13 and I get 3. I can choose 13 minus 10 and I get 3. 10 minus 7 and I get 3. If I were to choose two non-consecutive terms, I would have to divide by how many spaces those are apart. So for example, 16 minus 10, I'd get 6, but I know that those are two terms apart. So I have two common differences, so I would divide by 2, and my answer then is still 3. So this is called a common difference. Now our common difference in this case is positive. I can deal with common differences that add on to a sequence that is not an integer. So here I've got some decimals. I can also have a common difference that's negative. In this case, my common difference is negative 10. It's important that we talk about the common difference. Let's see. My common difference, we call it D. Common difference here is 2. The common difference here is minus 10. And it's important that you recognize that it's negative because that's going to make a big deal, a big difference when you go ahead and write your definition. And your definition is basically going to explain to someone else what that sequence is. So basically, arithmetic sequences are when you can add or subtract the exact same number from term to term to create our sequence. All right, explicit definition. Now, an explicit definition and a recursive definition are two ways of describing a sequence. Our recursive just says that if you want to find the next term, and our explicit is going to be basically to find any term. So explicit means you can find any term. Like you could name a specific term. I want to find the 51st term. Then you're going to use the explicit. Let's say I give you the 10th term and I want to know the 11th term. That would be the recursive. The recursive lets you find the next term. But you have to be given the previous term. So if you want to find the 4th, I've got to give you the 3rd. That's the recursive part. So there's kind of this things you need to know box in your head. Things you need to know. And these are need to know about these sequences. For example, you need to know the first term, and we call that A sub 1. So you need to know A sub 1, not A1, that's a steak sauce, A sub 1. So A sub 1 is your first term. You need to know that, and you also need to know the common difference. So both of these are going to have a numeric value. You need to know both of those in order to get going writing these, at least for now. We're going to work on other ways to do it. So for my explicit definition, to find any term we list as the nth term, A sub n, and that's going to equal the first term plus the common difference times n minus 1. Now n represents the number of term you're looking for. So if I want the 16th term, this would be a sub 16, and I would also choose to substitute in a 16 right here. Now I need to know the first term, and I also need to know the common difference. So those things over here are very important as I substitute them in. But this right here is my explicit definition, and you would replace it with a sub 1 and d just to write the definition. Then to find a term, which we'll do soon, then I substitute in the n value. All right, my recursive definition is much simpler because I'm not going to be using anything except a sub 1 and d. So my recursive definition begins with tell me what the first term is, and then we'll find the next term by taking the one you got plus the common difference. Okay, so if n represents any term we want, I have to, any term, and the one I want is the next. N plus 1 represents the next. N plus 1 is the next. So these two lines together are part of my recursive definition. You must include the a sub 1, you must include the first term when you write the recursive definition. It's the most forgotten thing, but it's incorrect to not have it. So these are your two definitions. You need to know those, to memorize those, and be able to use them. So let's go ahead and try to use them. So I'm going to do two examples of the explicit and two of the recursive, but I'm going to use two different sequences so we can get two different things going on here. So example number 1, I'm going to use 2, 6, 10, 14, comma, dot, dot, dot. All right. So we said the things you need to know were always that you need to know your first term and you need to know your d value. So my first term is 2, and my common difference is 4, because if I subtract any of those, I find that my common difference is 4. So my explicit definition went like this. A sub n equaled the first term plus the common difference times n minus 1. So now I'm going to substitute in the two values I know. A sub n equals the first term plus the common difference times n minus 1. This is my explicit definition. Let's write the same thing using, or write the recursive using the same sequence. Okay, for that one, we said we needed to write the first term, and I needed to write a sub n plus 1. The next term will equal the previous plus the common difference. Oops, I wanted to write a 4 there. So that is my answer for my recursive definition. Let's try another one real quickly. This one, 8, 3, negative 2, negative 7, and it's infinite. 8, 3, negative 2, negative 7. Okay, so again, the things I need to know are my first term and my common difference. So my common difference, remember you want to take the consecutive terms and subtract them. So I'm going to do 3 minus 8, and that gives me a negative 5. I also know it's going to be negative because the numbers seem to be decreasing. Okay, so using this right here, we're going to substitute in. I got a sub n will equal the first term plus the common difference, which I'm going to write as minus the common difference there, and then I've got n minus 1. That's my entire explicit definition. My recursive definition, in other words, how do I find the next term? Well, I start with a sub 1, and then I say my next term is equal to the one I've got minus 5. And this is my recursive definition. Questions that you have to class, or post them on Schoology, and we'll keep working together tomorrow.